Hi everyone, this is V. Srinivasa, Assistant Professor in Mathematics of Mlritm. So I'm doing continuously videos in the topic of multiple integrals. In last two videos, I explained how to evaluate double integrals when the limits are given. Now today I will explain when the limits are not given, just region is given, then how to evaluate double integral. So here we know that double integral evaluation is done by three ways. The first one is both are constants. That means here double integral means it needs two variables. Both x and y are constants. We can follow any order, first x and then y, or first y and then x. If one is constant and another one is in terms of that means x in terms of y and y constants, y in terms of x and x constants. Then we can follow a certain order. If y in terms of x and x constants, first we have to integrate with respect to y, keeping x terms constant, and then integrate the resultant with respect to x within the given limits, then we get the required answer. And the third one is if x in terms of y and y constants, we have to integrate first with respect to x within the given limits and then integrate with respect to y within the given limits, then we get the answer. So this is the way of evaluating double integrals. So here suppose limits are given, we can do easily. Limits are not given, we have to extract the limits from the given region of convergence. So region is given, then how to do the evaluation of double integrals. We'll see now with two examples. Yes, so here I selected one problem. Evaluate double integral over R xy dx dy, where R is a region bounded by x-axis and x is equal to 2a and the curve x square is equal to 4ay. First try to understand the given region. So here the region is bounded by x-axis. So now I'm drawing the x-axis and y-axis. This is x-axis, this is y-axis. So it is bounded by x-axis and x is equal to 2a. X is equal to 2a is the line parallel to y-axis. This is x is equal to 2a. It's the line x is equal to 2a. And the curve x square is equal to 4ay. So x square is equal to 4ay represents a parabola that having x even terms. X even terms means we have to draw the diagram vertically and y direction. If it has a y even terms, we will draw x direction. So x square is equal to 4ay, we have to draw like this. This is x square is equal to 4ay. So now x square is equal to 4ay. So this is the point we know 0, 0. And this is the point x is equal to 2a and x-axis y is equal to 0, that is 2a, 0. And this is the point of intersection of, so point of intersection of x square is equal to 4ay and x is equal to 2a. When I substitute x is equal to 2a in this x square is equal to 4ay, then what we get, this is 4a square is equal to 4a into y. This 4a square, a times cancel, y is equal to a. That means this is the point of intersection. So what is that point? 2a comma a. X coordinate is 2a, y coordinate is a. 2a comma a. This is 2a comma a. This is OAB. OAB. So this is the figure which is drawn by the given region. So in this region we have to evaluate the double integral. So it's clearly given the region bounded by x-axis and x is equal to 2a and the curve y square is equal to 4ay, that represented by the parabola. Right. From this we can get the x limits and y limits. Always think x is horizontal. X limits are horizontal. It moves vertically. And y limits are vertical. It moves horizontally. So here, and one is in terms of other variable, automatically second one is constants. So let I be the given integral. I is the given integral. So this is the given integral. Here from this figure we have to extract the limits. So x limits and y limits. X limits are, so here first of all given integral. Let I is the given integral. I is equal to double integral over R. This is the region R. Xy dx dy. Xy dx dy. So here double integral. Now x limits, we need x limits and y limits. It's very clear, this is y axis. Y axis means x is equal to 0. Y axis means x is equal to 0. That means x limits are, x in terms of y means this is the lower limit, this arc. This arc is represented by x square is equal to 4ay. From this x square is equal to 4ay, x is equal to root 4ay. Root 4ay means 2 root ay. This is x limits, x lower limit. So this is x lower limit. I am writing the limits. X is equal to 2 root ay to upper limit. So this is the lower limit, this is the upper limit. X running from this to this. Already I said x is horizontal. So it moves from this to this. So that is x is equal to root 2 root ay to x is equal to 2a. These are the x limits. Then y limits. Y limits means vertical. So y is 0 to a or 0 to a. Those are the y limits. So y is equal to 0 to a. Xy dx dy. So here it's very clear. After getting the limits, we can easily identify x in terms of y and y constants. First we have to integrate with respect to x, keeping y terms constant, and then with respect to y. So this is equal to integral 0 to a. First I am doing with respect to x, keeping y terms constant. Integral of x dx is x square by 2. Within the limits 2 root ay to 2a into dy. So that is equal to, when I apply the upper minus lower limits, this is integral 0 to a, y by 2 is constant. First upper limit. Upper limit is, this is 4a whole, 2a whole square, that is 4a square, minus 2 root ay to root ay whole square, that is 4ay into dy. Now this is all in terms of y and constants. This can be complete by doing with respect to y. So here I am splitting the terms, integral 0 to a, y by 2 into 4a square. 2 in 4, 2 times cancel, 2a square into y. That is the first term. Minus 2 in 4a, 2a times cancel, 2a y square, y into y, y square dy. Now it's time for doing with respect to y. So that is equal to 2a square into integral of y dy, y square by 2, minus 2a integral of y square, y cube by 3. Within the limits 0 to a. Then we can substitute upper minus lower limits. So that is upper limit, this 2 cancel. Then when I substitute in place of y a, this becomes a square into a square, a power 4, minus, when I substitute in the second term upper limit, 2a by 3 into a cube, that is 2a power 4 by 3. When I substitute y value 0 as a lower limit, we get answer is 0. So here when I take 3 is LCM, 3a power 4 minus 2a power 4, a power 4, a power 4 by 3. This is the answer. So it's very easy. First we have to identify it. That is the important task. Most of the students feel that is difficult. So one that is very easy if we have the small basics of coordinate geometry, not in-depth basics, just basic knowledge for coordinate geometry. We can easily identify the limits by drawing the rough sketch. So here given limits are, it is bounded by, given region is bounded by x axis, x is equal to 2a, x square is equal to 4ay. So we know x-axis which is drawn horizontally. X is equal to 2a. That is a line which is parallel to y-axis. That is 2a distance. X is equal to 2a. And x square is equal to 4ay. That is the parabola which can be drawn vertically. X square is equal to 4a. Now in this region we have to integrate. From this we can easily get the limits. So here x in terms of y, y constants. Otherwise y in terms of x, x constants. It's very clear to say that this is the lower limit, this is the upper limit, this is the path. So x is x limits are taking from this parabola to line. So this parabola is x square is equal to 4ay. So x is equal to root 4ay. That is 2 root ay. We got lower limit. And coming to the upper limit, that is what is the edge, end edge. This is the two edges. One edge is lies on parabola, one edge is lies on line x is equal to 2a. So upper limit is x is equal to 2a. So this is the way of getting x limits. Then coming to the y limits, y means it's a vertical strip. In this vertical strip, it's very clear. So this from vertical strip, one edge is here, another edge is here. So here y coordinate 0, here y coordinate is a. So 0 to a. Y limits are 0 to a. X limits are 2 root ay to 2a. First we have to integrate with respect to x because y in terms of x is there, keeping y terms constant. So here that's what here y constant, integral of x is x square by 2. So I applied the limits 2 root ay to 2a. Upper minus lower limits. This is the mathematical steps we know, that everyone knows that. So here that is x in place of x, when I substitute 2a, 4a square. X square means 2a whole square, 4a square. So and when I substitute lower limit in place of x, if I substitute 2 root ay, x square means 4ay. So here now all in terms of y we got. So with constants. Now it's time for doing with respect to y. 2a square y minus 2ay square dy. So here we know integral of y. So here in most of the problems we can use the standard formula integral of x power n. Integral of x power n dx is equal to x power n plus 1 by n plus 1. We will use this formula in most of the problems. So here integral of y, y square by 2. And integral of y square, y cube by 3. I apply the limits. In place of y, I substituted upper limit a, lower limit 0. When I substitute lower limit 0, automatically we get the answer 0. When I substitute upper limit, so this is a square into a square, a power 4, minus 2 by 3 a into a cube, 2a power 4 by 3. And the final answer is a power 4 by 3. So I hope everyone understood this one easily. So the important one is taking the limits. Right. I will explain one more problem in the same scenario. So limits are not given when region is given. Right. This is a question. Next question what I selected. Evaluate double integral x square plus y square dx dy in the positive quadrant for which x plus y less than or equals to 1. So here also one double integral is given, no limits are specified, but one region is given where we have to evaluate this double integral in the given region. That region is bounded by positive quadrant for which x plus y is less than or equals to 1. The first thing is we have to draw the rough sketch. When we draw the figure, then we get the clarity how to take the limits. So here, so x-axis and y-axis. This is x-axis, this is y-axis. Now x plus y is equal less than or equals to 1. First of all, what is x plus y is equal to 1? It represents what? So it represents circle, hyperbola, parabola, line. What it represents, that student can identify. This is possible only if they have basics of coordinate geometry. So this is very clear to say that this is a line. X plus y is equal to 1 is a line. The line joining the 2 points. What are the points? So here on x-axis we know that on x-axis y coordinate is 0. Substitute y is equal to 0, then what is x? 1. So that means one point is 1 comma 0. On x-axis, the line touches at a point 1 comma 0, right? And on y-axis, we know on y-axis x coordinate is 0 and x 0. We can take x is equal to 0 in this equation. Then what we get? 0 plus y is equal to 1. That implies y is equal to 1. So that means this equation, this point is 0 comma 1. On x-axis, what is the point? 1 comma 0. On y-axis, what is the point? 0 comma 1. The line joining these 2 points represented by x plus y is equal to 1. When I draw the line joining these 2 points, this is the line x plus y is equal to 1. That's very clear. And as per the given statement, x plus y less than or equals to 1. That means here we have one doubt. This is below part we have to consider or above part we have to consider? Above part means x plus y greater than 1. Below part means x plus y less than or equals to 1. So here x plus y less than or equals to 1 means in this region we have to integrate. So here this is, we know, obviously 0 comma 0. So x-axis means y is equal to 0. Y-axis means x is equal to 0. This is x plus y is equal to 1. Now here two ways of getting limits. First of all, let I is the given integral. Given one is double integral of x square plus y square dx dy. So here there are two ways to get the limits from this figure. One, x in terms of y, y constants, or else y in terms of x, x constants. So it's very clear, when I take x limits, x is equal to 0 to, it starts, we know x means it's a horizontal strip, y means it's a vertical strip. X limits 0 to x plus y is equal to 1. So that means x limits are from y axis to this line x plus y is equal to 1. That means what are the x limits? X limits are 0 to 1 minus y. So then y limits. Y limits means this is a vertical strip. From this vertical strip, y limits are 0 to 1. Y limits are 0 to 1. This is one way. And another way also there. So here I will take y in terms of x. That means this is first y limits. I will take first y limits, y in terms of x. What is y lower limit? Lower edge is on y is equal to 0. So y is equal to 0. 2. Upper edge is on the line x plus y is equal to 1. That means what is y? 1 minus x. Y is equal to 1 minus x. This is a y in terms of x. Then x constants. X limits are now 0 to 1. X limits are 0 to 1. Either we can follow these limits or these limits, we get the same answer. So here I am explaining two ways of evaluating this based on the given region. Right. Now here this is the double integral I is equal to y in terms of x or x constants. So that means y is equal to 0 to 1 minus x. Y is equal to 0 to 1 minus x. And x limits are 0 to 1. So here x square plus y square, first I wrote y in terms of x. That's what with respect to y. And then x. Any pattern we can follow. So that is equal to, first what I have to do with respect to y, keeping x terms constant. So that is integral 0 to 1, integral of, this is x terms constant, x square into integral of 1 dy, that is y, plus next integral of y square. Integral of y square is y cube by 3. Then what are the y limits? 0 to 1 minus x dx. So now in place of y, we have to substitute x limits. That is equal to integral 0 to 1 x square into 1 minus x. In place of y, I am substituting upper limit and then lower limit, plus 1 minus x whole cube by 3. When I substitute lower limit, in place of y 0, then whole answer is 0 into dx. So that is equal to integral 0 to 1 x square into 1 x square minus x square into x cube plus 1 minus x cube by 3 into dx. Now it's time for doing with respect to x. All terms expressed in terms of x only. So finally we have to do with respect to x within the limits 0 to 1. So that is equal to integral of x square x cube by 3 minus integral of x cube x power 4 by 4 plus, actually it's looking like x cube. So here two ways of evaluation, by expanding a minus b whole cube or directly by applying the formula x power n. 1 minus x whole cube, 1 minus x whole cube derivative 1 minus x whole power 4 by 4, 4 already 3 is here, 4 into 3 into denominator having derivative of 1 minus x, that is into minus 1 within the limit 0 to 1. So it's very clear to observe 1 minus x whole cube by taking as x cube x power 4 by 4 into internal derivative in the denominator. For integration we have to take internal derivative in the denominator. For differentiation we have to take internal derivative on the numerator. That's a simple principle. So here 1 minus x derivative minus 1. So when I substitute the upper limit, first 1, so that is 1 by 3 minus 1 by 4, and this is plus minus minus 1. When I substitute 1, 1 minus 1, 0. This is 0. This is upper limit minus lower limit. When I substitute 0, first term 0, second term 0. Only last term, third term. In third term x is 0. Then what we get? That is 1 minus 0, 1 power 4. 1 power 4 by minus 12. That is minus 1 by 12. So 1 by 3 minus 1 by 4, 12 is LCM. 12 is LCM. Then that is 4 minus 1, 3. So 4 minus 3, 1 by 12. 1 by 12. And this minus minus plus 1 by 12. 2 by 12, answer is 1 by 6. So it's very clear once again. So here the region is bounded by one line and the coordinate axis. What is that line? X plus y less than or equals to 1. First we have to draw the line joining the points 0, 1 and 1, 0. That is x plus y is equal to 1. So here we want less than, x plus y less than equals to 1. Less than or equals to gives lower part. Greater than gives upper part. So in this region we have to integrate. So in this region first we have to get the limits. So here point 0, 0, 1, 0, 0, 1. That are the point of intersections. Now here two ways I explain, either x in terms of y constants, or y in terms of x and x constants. So here if I consider first x limits are 0 to 1 minus y. Then y limits are 0 to 1. That is one way. And the another way is, if I consider y limits first in terms of x, y limits 0 to this line, that is equal to 1 minus x. And x limits are 0 to 1. That is the second way. You can follow with any limits. So here y limits 0 to 1 minus x, x limits 0 to 1, x square plus y square dy dx. So here first I am doing with respect to y, because y limits are there. Keeping x terms constant, integral of x square dy. So x square into y. Integral of x square dy is keeping x terms constant, x square into y, plus integral of y square y cube by 3 within the limit 0 to 1 minus x dx. When I substitute the limits, where I have to substitute in place of y. So that is x square into 1 minus y plus 1 minus x whole cube by 3 into dx. So that is equal to integral 0 to 1 x square into 1 x square minus x square into x cube plus 1 minus x whole cube by 3 dx. So here now entire expression in terms of x. Now we have to integrate with respect to x within the limits 0 to 1. Within the limits 0 to 1. right? So here integral of x square, x cube by 3 minus integral of x cube, x power 4 by 4. Here one of the formula, this is one of the important point, everyone have to identify this formula. 1 minus x whole cube is looking like x cube. X cube integration x power 4 by 4. But it's not x, 1 minus x. We need to write internal derivative in denominator because it is integration. So that's what 1 minus x derivative is minus 1. I wrote in the denominator. Limits 0 to 1. So that's what here when I apply the upper minus lower limits, upper limit 1 by 3 minus lower limit 1 by 4. And when I substitute 1 minus 1, it's a 0. This is upper limit. Minus lower limit is 0. When I substitute in place of x 0, so first term 0, second term 0, and third term is 1 minus 0 power 4, 1 power 4 by minus 12. So that is minus 1 by 12. So already here 1 by 3 minus 1 by 4. 1 by 3 minus 1 by 4, when I take 12 LCM, 3 in 12 4 times, minus 4 in 12 3 times. 4 minus 3, 1 by 12. So already here minus is there, minus plus 1 by 12. 1 by 12 plus 1 by 12, 2 by 12. 2 by 12 means 1 by 6. That is the answer. I hope everyone understood well. This is the concept of evaluation of double integrals when the limits are not given, when the region is given, how to do. Right. Thank you to everyone.